In this short tutorial, we're going to download publicly available data from the COVID Trends and Impact Survey, likely one of the largest health surveys ever conducted. It's conducted in partnership with Facebook, the University of Maryland, and Carnegie Mellon University. And this vast data set has been running since April 2020, containing COVID-19 related metrics from millions of respondents around the world, from symptoms they report to attitudes towards vaccines. Now, it's important to mention that because this survey collects health information, it has a unique configuration compared to other data for goods surveys and data sets. Unlike those data sets, data from this survey is collected off of the Facebook platform, and it's shared by our academic partners, UMD for global data and CMU for US data. Now, this way, Facebook helps to promote the distribution of the survey, but does not see any individual responses. We do share a survey weight that helps researchers correct for sampling bias, but that does not identify anyone. So we'll be using a public data set from UMD that helps answer questions like, how are symptoms related to COVID-19 increasing or decreasing in particular regions? Or what are people's attitudes and practices towards vaccines and preventative behaviors? Now, we've already seen this data being used in the real world. A June 2021 paper published by Johns Hopkins University in Science used this data set to find that within the United States, people living with a child attending school in person had an increased risk of COVID-19 related outcomes. It also found that school-based mitigation measures like daily symptom screens, teacher masking, and closure of extracurricular activities are all associated with significant reductions in risk. Now, you can imagine from a policy perspective how useful these insights and this data can be to inform future responses to pandemics. Now, check out the link in the description below to follow this case study more closely, and let's get started with the tutorial. So let's get started by accessing the data itself. Now, the global data, the non-US data from the COVID-19 Trends and Impact Survey is available by the University of Maryland. So you can check out the URL here on the screen to access this data set. And there's also at the very bottom what are called contingency tables. These are the data sets that we're going to look at today. Now, once you open or click on this link, it gets pretty intimidating. You start seeing that these contingency tables, which are essentially a wide variety of different configurations of the data that have been prepared and shared on a weekly and monthly basis, are available in different folders. We're going to click on this folder here, Contingency Tables version 1.0, and that'll take us to this big list of dozens and dozens of weekly and monthly zip files. Now, I know this feels like a lot, and it was for me too. One of the most valuable things we'll get from this tutorial is just basically understanding how to interpret this data. The visualization will be a really small part of this tutorial. Essentially what we have here, if you look closely, is each file is a time of year, a date stamp, in this case beginning with 2020, April 26th. And these are offered either as weekly files or monthly files. So you could get a file that includes data just from the week or from the entire month. Now, we're going to get the latest data. So scroll down to the bottom. The latest monthly data that's available is from 2021, August 1st. So go ahead and download that file. The other thing I'd like you to do is on the main page, go back and make sure you open and download the Readme file. Now, the Readme file will give you all kinds of really important information that we'll consult regularly. So once you've downloaded that zip file, go ahead and unzip it and take a look at what you see. Now, this is really fascinating. Inside each one of these folders, we have 64 individual files that you can open. Now, these are the actual contingency tables, and let's take a look at what each one actually means in detail. The first part of the file name of the first one here is basically the date again. And you can see here it's from August 1st to August 31st, 2021. And this corresponds to the file that we downloaded, which was August 2021. It's reminding us that this is a monthly data set. It's also reminding us or letting us know that it's broken down by country. And this last section here is letting us know how else it's broken down, in this case by age. But as you can see here, there are 64 different demographic or other breakdowns or contingencies that are available. You can break it down by age and by gender, by the education level, by the comorbidities that may be related to cancer or diabetes, by the industry that they work with, by whether or not they're a smoker, by whether or not they live in an urban area, and so many more. In our case, I'd love to see if there are any gender differences in a particular data set, so I'm going to open up the monthly country gender data set.
Now, once you've opened this data set, one of the first things that you'll notice is the sheer size of it. It's a very wide data set with over 1,000 columns. So what that means is, rather than show you what each and every column means individually, through this tutorial, I'm going to explain how we can use the README file to decipher the dataset using one specific example and only a few of these columns. Once you practice that foundation, you'll be able to apply it elsewhere in the dataset according to your research needs. But first, let's get acquainted with the first few columns of this dataset. I'm going to zoom in a little bit here so it's easier for you to follow along on the screen recording. Let's look at columns A through M. Now, these columns contain important information about each record, like the start and end date of this report. So for example, column B reminds us that the period start date is 2021-08-01 or August 1st, 2021. Column H tells us the country that we're looking at. Now, column G reminds us of the aggregation type that we chose. You'll recall that over in our zip file, we opened the file ending with gender. And so we're seeing here in our data set that a reminder that the aggregation type that we chose is gender. In fact, over in column M, you'll see that aggregation type, gender, listed in the column header with the options below it. If we had instead chosen to open a different file, like one ending with education level, we would see education level listed here instead. Now finally, for each row or record of this data set, we can see the response for different questions according to the country, gender, and time period. So for instance, row 11 shows the responses for female respondents in Argentina in August 2021. Now you'll notice that each country is repeated several times, and that's because it's once for each gender option, like female, male, other, or NA, or not applicable, which covers respondents who did not provide a response to the gender question. Now, as a reminder, we'll only see values for any disaggregation in this data set where there were enough responses to preserve privacy. So how do we start looking at the responses to specific survey questions? Well, that's where the columns beginning at column N really come in handy. So the first important thing to note when looking to see responses to certain questions is that each survey question is represented in this dataset as an indicator, which is basically a short name or code name representing a specific response option to a survey question. Now, you can see a list of all of these indicators and the survey questions they correspond to in the README file in this large table starting on page 10. Now, for example, the indicator vaccinated, appointment, or accept refers to the percentage of those who have either already received a COVID vaccine, have an appointment, or would definitely or probably choose to get vaccinated. Now, this particular indicator, by the way, is one of the variables most often used in this data set to understand vaccine behaviors. So if we jump back into our data set and search for that indicator name, which was vaccinated _appointment _or _accept, you'll see it'll jump us to that column that contains that indicator, as you can see it at the top of this file. So later on, we'll consult this same README file to find the questions and response options and the indicators that are most interesting to our research inquiry. We'll figure out what indicator that is by looking at the second column here, and then we'll search that indicator in the actual data set to find the corresponding values. The second important thing to note is that, like with this vaccinated, appointment, or accept indicator, each indicator has 4 columns dedicated to it in the dataset. Now, this part will get a little bit technical, but it's really important that even non-technical users have a grasp about some of these statistical concepts. The first column begins with VAL _ or value. Now, this is the main value of interest for that indicator, like the percent, the number, or the count. Now, keep in mind that the values in this column have already been weighted. What that means is that the raw responses from the sample have been adjusted to represent the broader population. This is important because it gives you a more confidence that the value is representative of more than just the relatively small pool of people who responded to the survey. If you'd like to learn more about how the survey was issued, the sampling method, or how weights were calculated, make sure you check out this resource. Now, the second column begins with the prefix SE, which stands for the standard error. The standard error is a statistical term that measures the precision of an indicator from a sample with respect to the population value. Now, the higher this value, the higher the uncertainty around the estimate. For example, in rows 15 to 16, which are for the country Armenia, you'll see that the standard error for this indicator is 3.1 for females and 2.85 for males. This means that the value for males in the column beginning with VAL_, is more likely to be more precise than the value for females. Now, there's no right or wrong SE or standard error value for any survey. Having a higher SE value doesn't necessarily discount the findings. But generally speaking, you should look at this value when interpreting any finding because it provides you with a more complete picture about the uncertainty of these statistics. So back to those 4 columns for each indicator. The third column, beginning with sample_size, is the number of survey respondents used to calculate the indicator. As you might imagine, generally speaking, larger sample sizes are preferred to smaller ones because it makes it easier to more accurately draw conclusions about the broader population. Now finally, the fourth column for each indicator has the prefix represented, which provides the number of people in the population that this indicator represents, added up over all days in the given time period. Now look, for the purposes of this tutorial, we're going to focus primarily on the first column for each indicator, the actual value, and chances are you'll do the same when using this data set. But whenever you do, pay close attention to these other variables to get a better picture of the statistics. And if you're going to be using this data to inform any research or decision, be sure to visit the Survey Limitations page here, which provides some more context and practical recommendations to guide responsible use of this data. So now we understand the basic structure of this data set, and like I said at the beginning, for this particular data set, understanding this structure really is more than half the battle when it comes to making sense of the findings. So now let's get on to the good stuff. Let's answer some real-world questions using this data set. And with a survey like this, there are some good and bad practices about what questions it's best suited for. For example, these insights can be great for finding trends or correlations between signals, but they should not be used as valid estimates of the prevalence of specific behaviors or conditions, like people who have tested for COVID in a given point of time. So with that in mind, let's try to discover whether a correlation exists between 2 variables in this data set. Let's imagine that I'm interested to know if there was a relationship between vaccine acceptance and what news sources people receive their COVID-19 news from. The best way that I've found to begin exploring these correlations is to look at the Readme file and find variables that are of interest to you and to your research questions in that long table of indicators I looked at earlier. So you might recall, for instance, we looked at this one here, vaccinated, appointment, or accept, which is the percentage of respondents who have either already received a COVID vaccine, have an appointment, or would definitely or probably choose to get vaccinated. Now you also recall we were looking at any relationship between that and where people get their news from. If we scroll down to page 30 on this table, we have several indicators that talk about news sources as it pertains to COVID-19. This one here, for instance, received news government health, is the percentage of respondents reporting having received news about COVID-19 in the past 7 days from government health authorities or officials. And you can see there are a few other similar indicators like the one 2 rows below, which is the same thing but regarding local health workers, clinics, and community organizations. So wouldn't it be fascinating to see if there was a correlation between these variables? Are people who get COVID-19 news from official government health authorities or local authorities also those who are more accepting of vaccines? And is there a difference between male and female respondents? Now that we've identified these 2 indicators in the Readme file, what we'll do is we'll create a new spreadsheet over in our Excel file that pulls the values for those indicators from the bigger data set into a new, clean, simplified spreadsheet. Once we're done with that, we can get to work visualizing the data to see if there's a correlation. So I'll begin by creating a new blank sheet in our dataset file. Then I'm going to go back into the main dataset and just pull some basic important columns from there, like the country and the gender. So I'll copy those over, bring them over to our blank sheet and paste them here. So next, let's paste in the values for each of these countries for those indicators we were looking at earlier. The easiest way to do this is to just find the indicator name in the README and then search for it in the dataset, like we were earlier. So here we'll search for this, for the first variable here. It'll jump us to column LZ. I'll simply copy that entire column and bring it over here and paste it. And then we'll do the same thing for the received news from government indicator. I'm just going to type that in here and search for it again here. Now that should take us to the indicator here, column ACH. And again, as we know, there are 4 columns for each one of these. We're going to pull a value. So we'll look at columns ACH, copy that over. And then just for fun, to see if there's any differences and correlations, let's also bring over that indicator about those who receive news from local authorities. And I think that ended with local health. So let me jump back here, search for that one. And that should jump us to the right column. Here it is. And again, we'll take the value prefix, copy that, and bring it over to our blank, our new spreadsheet here. Now we have just a little bit of cleanup to do on this data set before visualizing it to find any correlations. Let's begin by sorting out all of the other or NA or not applicable gender options, because not all countries had an other option and the NA doesn't really tell us too much information about gender. So let me zoom in to make it easier for you to follow me along here. And I'm just going to highlight the top of these 5 columns, click data, and then click filter. And then on top of gender at the arrow, I'm going to uncheck NA and uncheck other. Now that should leave us with just 2 rows for each country, one for female and one for male. Now the last little trick I'll do here is just clean up this data set by changing the NA to blank cells. What I've done here is I'll hit our find and replace window and I'll search for NA. I will match case and match the entire cell contents. And what I'll replace it with is nothing, just to make it blank. Then I'll click replace all. We've got 17 replacements, which is great. And now we're ready to go. Now, before we start visualizing this, I just want you to take a second to appreciate how far we and you have gone in just a few minutes. I mean, we started with a data set that was hard to decipher, that had 1,000+ columns in it. And we used the README file to look for just the indicators and questions that we cared about, extract them, and transform from a large, complex data set into a more manageable file that we can start to actually make sense of. This is such a big step to making sense of these large, intimidating data sets. And from here on out, the steps will be less technical and a little bit fun as we start visualizing to search for a correlation. So let's use one of my favorite tools called Flourish to visualize this data set. Head over to www.flourish.studio to find a beautiful and easy tool for data visualization and storytelling. Now, there are a few reasons I love this particular tool. Very briefly, first of all, it's really easy to use and easy to develop a wide diversity of different chart styles. Secondly, in addition to being able to create specific visuals, you can also combine those visuals and using some other features to develop an actual presentation that has interactive features into it and share that presentation publicly. And thirdly, although there are pricing plans involved, there are also a free plan that you can use, but just be mindful of the different data privacy differences between different pricing plans. So I'm going to sign in using my free plan, and I've just linked that to my Google account. And when I do that, I get right in here to my dashboard. Now, yours may look somewhat different to this, but just be mindful that at the very top, you can create 2 different types of elements. First, just a specific discrete visualization. And second, you can create a new story, which is basically several visualizations combined with some other elements like titles and text and animations to tell a compelling story via a presentation that you can download, export, or share as an online link. Let's get started by clicking New Visualization, and that'll take us to an opportunity to select the specific template that we'd like to use. Now, generally speaking, when you're looking for correlations, a scatter plot is going to be your most powerful and relevant visual type. So we'll click on a basic scatter plot here at the bottom, but take note of the huge collection of different templates they have available. Now, once you're there, let's start off by giving this visualization a title. In this case, we can call this the CTIS, or COVID Trends and Impact Survey Analysis. Now, the interface here is really straightforward. In the center of the screen, you have your preview of the actual chart. On the right side, you can select different parameters and customizations for that chart. At the top, you can toggle between the preview feature, which is what we're looking at right now, and the actual source data itself in a relatively familiar looking spreadsheet style. Finally, at the top right, you have options to convert this to a story, which I talked about previously, or export and publish the visual to share with others. So we'll get started here first by, in our data tab, just replacing the dummy data that existed before with the data that we created over in our spreadsheet. So let's highlight those columns, copy them, jump back to Flourish. And at the very top left, we can click there and just paste our data in. And you'll see it will replace the old data with our new data set that we care about here. Now, the next thing we do basically is configure what elements of the chart should correspond to which columns of this data set. So if we imagine a scatter plot right now, for the X values or the X axis, let's have that be the variable vaccinated, appointment, or accept. So we'll just change from A here to column C. And then for our Y values, let's do the variable receive news from government health authorities, and that's column D. So we'll click D. There's a couple other small features we can do here. When you actually mouse over a specific point on the scatter plot, you can get a name to appear, and we can actually do multiple names. Let's do the country and the gender here, so we'll be able to see that. And then finally, we wanted to see if there were any difference in correlation between female and male genders, and so we can actually color the dots according to the gender. So we'll do column B for this one. And the last thing we'll do here is we'll add a little filter, and you'll see this in a second, enabling a user to toggle between both genders, only female or male. And for that control, we'll assign that to column B so that the system knows to use those two options. Now, if you look closely on the screen share, one of the things you will have noticed is as I was changing these column assignments, the visual at the bottom right started updating. This is one of my favorite features of Flourish, which is as you make individual tweaks, you get to see those changes in real time to the visualization itself. So now that we have the infrastructure of this visual sorted out, let's head over to the preview tab and make some stylistic changes to the scatter plot that we've developed here. Now, there's lots of different options for this section, and I'm just going to focus on a few. The first one is our y-axis, and I'm going to change it so that the y-axis begins at 0. And so we'll set a minimum of 0 here. And I'll also change it so that the max is 100. And this will just give us a more accurate picture of the actual extent of any correlation. The next thing I'll do is close this particular y-axis dropdown and open the one about the filter. Now, you'll recall in the data tab, we assigned the column for gender as a filter. And I'm just going to show you how you can change the control type. Right now you have this dropdown at the top left of the visual, but I kind of like these buttons here that let you toggle between all genders, female and male respondents. A really cool feature of interactivity here that I think is useful. And finally, just to help understand if there's some sort of a correlation here, I'm going to close this one and open up the trend lines option, and I'm going to ask it to show one trend line per discrete color. So we can see a trend line of correlation between both for this particular indicator, and we'll see them developed here. Well, we're really getting somewhere now, right? Now that we've had this data visualized, we can step back and see what it's really telling us. The trend line suggests that there is some sort of a correlation potentially between these two variables. So generally speaking, people who have already received a COVID vaccine, have an appointment, or definitely probably choose to get vaccinated, are also likely to have reported having received news about COVID-19 in the past 7 days from government health authorities or officials. Now, of course, this is a really elementary correlation. If you wanted to make any decision out of this data, you might first want to introduce or isolate additional variables to properly understand the nature and strength of a more nuanced correlation. We should also be mindful of those other columns in the data set for the values of each indicator, like the standard error, before drawing any conclusions. But that aside, in terms of giving us a basic understanding of how two important indicators are related in the fight against the vaccine, This is not a bad start at all. So assuming we're happy to share this out with someone, let me show you a couple of last final steps to finalize the styles and export this to share with someone else. Let's start by looking at the right-hand side at the title dropdown under header. And here let's add a title here that just helps to give a bit more context about what this particular visual is. So maybe something like, is vaccine acceptance correlated with news intake from government health authorities? You can see once I do that, it'll add the title at the very top there. Now it's also really important to provide the source for any particular visual you make here, and Flourish does a great job of providing a space for a footer where you can type in the source name and also the URL. And you'll see here, it'll add a little bit of a link at the bottom of the visual. So I'm pretty happy with how this looks. Of course, you could customize and change the names of your particular axes and other things as well, like the colors. But assuming we're ready to share this, the next thing you do is click this Export and Publish button at the top right. And here there are a few options. The first thing you want to do is publish to share and embed. You can also download an image of this if you want to just kind of embed it into an existing resource that you have, like a blog or a presentation. But let's click Publish. You want to make sure that you click Publish one more time here. And what you'll see then is a unique link that you can copy and open in a new tab to see the visual. And this is a link you can now share with absolutely everyone who might be interested in the specific insights. And there you have it. In a few minutes, you've gone from a pretty complicated set of online contingency tables. We've opened the file that we care about based on the disaggregation that we wanted to know about. We consulted the README file to find the indicators that we cared about in the actual data set. And then we took out the values that we cared about for those indicators from this 1,000 column wide data set and put them into a clean, simplified, shorter data set right here that we then uploaded into Flourish to get this correlation.
This is one of my favorite tutorials because it makes it easier to access and understand data that, as we've seen during the COVID-19 pandemic, can be truly life-saving. The CTIS data is really a treasure trove of insights across a wide range of variables. I mean, we only focus on a couple here today, but as you saw, there are hundreds more to explore. And these variables are shared in so many different dimensions, like age, education level, and more. And what's even more exciting to us is the contrast between how the data looked when we first encountered it, a series of links on a web page, to how it looks after a bit of data cleaning and easy visualization. So there you have it. If you're looking for more tutorials like this, check out the playlist link in the video description below. There, you'll also find important resources, including links to the case study I mentioned earlier, as well as the methodology used by Facebook's university partners, UMD and CMU, to develop and privacy preserve these data sets. There are also a few links to some great dashboards that let you visualize and explore aggregate data from the COVID Trends and Impact Survey. And before you go, please help us improve these tutorials. Take the short survey that you've seen on your screen here to let us know your thoughts and see how you might use these insights. We'll talk to you soon.